So in this video, we're going to be talking about these problems having to do with half-lives, all right? And even though there are some equations that you can use for figuring out half-lives, all of these problems are going to be ones that you can figure out basically on, by applying some logic, all right? So the first question, what is the half-life of a 100-gram sample of nitrogen-16 that decays to 12.5 grams in this much time? All right, so the thing about half-life, that's the amount of time that it takes for something to get the amount of something to get cut in half. All right, so for this case, one half-life would be the amount of time that it takes to go from 100 grams to 50 grams. All right, but the thing is, that would be the same amount of time that it would take for 50 grams of that to get cut into 25 grams. And so what we're going to do is we're going to keep on doing this until we get down to that amount. All right, so you cut that in half again, and we get down to that 12.5 grams that they mentioned. All right, so this would be one half-life, and the way that they represent half-life is T with a little 1/2 subscript there. This would be, so however long it took to do this is the same amount of time it takes to do this, which is the same amount that it takes to do that. All right. Well, the thing about it is that we know that the total amount of time is 21.6 seconds. All right. So to figure out how much one of these would be, well, we know that there are 3 total half-lives that are involved. We figured that out based on this right here. So the amount of each of these would just be 1/3 of that. All right, so you just take your calculator, punch those numbers in, and we can calculate that each of these half-lives here would be 7.2 seconds. The next problem is very similar. We're going to take an 800-gram sample. One thing about these, a lot of times you see this little number, all right, technetium 99. All right, that number never really gets used in the math. All right, that's just the name of that particular isotope. All right, so it's going to go from, so we want to see how long it would take for it to get to 100 grams. All right, so that cutting that in half would be 400. Cutting that in half again would be 200. Cutting that in half would take it to 100. All right, so the amount of time that occurs is one half-life. The amount of time for that is another half-life. That is a third half-life. All right, so it says that it takes a total amount of time to go, so this entire time to go from 800 to 100 is 639,000 years. All right, and again, the length of time for the half-lives can be a really short amount of time, like seconds or parts of a second, to many thousands of years. So just realize don't get worried if your number seems really high or really low. All right, and there are 1, 2, 3 of these half-lives in there. So take that number and divide it by 3. And so that you can figure out that the half-life would be 213,000 years. All right, this problem right here, we've got a 208-gram sample, and it decays to that amount, 13. All right, so let's figure out how many half-lives that would be. 208 to 104 to 52 to 36. Sorry, that would be 26, and then finally to 13 grams. All right, and don't worry about significant figures in these problems. I'm not going to be grading on significant figures for these types of half-life problems. All right, so that is 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. It says that the total amount of time is 60 hours, 60.0 hours. So 60 divided by 4. Okay, so each one of those half-lives would be 15 hours. So this next problem is a little different. It starts by telling you how long the half-life is. And then it asks you how long it would take you to get from a starting amount, which is this, to an ending amount, which would be this. All right, so let's see if, let's see if we can figure out how many half-lives are involved in going from here to here. All right, so you go from 50 to 25 to 12.5 to 6.25. All right, so that is 1, 2, 3 half-lives that are involved there. And if each of those is 8.10 days, 8.10, 8.10, that means that the total amount of time would be 3 times that amount. So 3 times 8.10, and that would add up to 24.3 days. All right, the next problem, we've got a half-life of 0.025 seconds. So you can write that T1 half equals 0.025 seconds. All right, how long would it take something that is 560 grams to decay to 1/4 of its original mass? All right, so to go to 1/2 of its mass, to go to 1/2 of its original mass, that would be going down to let me see. That would be going down to 280, and half of that again would be 140. So this right here is 1/4 of its original mass. All right, so 4 times 140 gives 560. How long would that take? All right, well, that is the period of time. That would be 2 half-lives. So that amount of time right there, that's, notice that that's the amount of time that it takes its mass to get cut in half. And then another half-life there. So that would be 2 of those half-lives, so it's just double that amount. All right, so that would be 0.050 seconds. So in this one, we know that the half-life is 21.6 hours. So how long is it going to take to get from 360 grams to 11.25? All right, so let's just keep on cutting this in half. That cut in half would be 180. That cut in half would be 90. That cut in half would be 45. That cut in half would be 45 cut in half would be 22.5. Cutting it in half again, 11.25, which is where we're at. All right, so that is 1, 2, 3, 4, 5 half-lives. All right, and if each of those half-lives is 21.6 hours, we'll just multiply that, and we get 108 hours. Okay. Potassium 42 has a half-life of 12.4, so half-life is 12.4 hours. All right, how much of that sample would be left after 62 hours? So we could start this problem by just starting to cut this amount in half. We know that after each half-life, the amount remaining is half what it was before. And we know that the amount of time that it takes each of these to happen is 12.4 hours. All right, so the thing is we're trying to get to the, make it so that the total amount of time would be 62 hours. So one way that we could do that is to try to find out how many times 12.4 would go into 62. All right, and we can see that that happens a total of 5 times. All right, so that is 1, 2, 3, and we need to do it 2 more times. All right, so breaking that in half, that would be 53. All right, so that's 12.4 hours, and then taking 53 and dividing that by 2, 53 divided by 2 is, that's going to give us 26.5. All right, but the, so that's another 12.4. So this is, again, the key thing is that this amount right here, the 26.5 grams, that's how much would be left after you allow it to get cut in half a total of 5 times, all right? Because if that's the total amount of time and that's the half-life, there are 5 of these amounts of time in that total amount of time. All right, so the answer would be 26.5. All right, So in this case, they give a half-life, which we have right here. And they're asking how much of this will be left after this many years. All right, so this is given in scientific notation. Let's make this a little simpler by representing it as a regular number. So let's just move the decimal point 1, 2, 3, and then we need to add one more 0. So that's going to be a total of 17,190 years. Okay, so that's the total amount of time. All right, so if this is the half-life right here, and this is the total amount of time that we're going to allow something to decay, we can figure out how many times the half-life goes into that. All right, so we can do that just by dividing it. And that's going to give us the number of half-lives. And so that number is 3. All right, so that tells us that we want to start with, if we're starting with 144 grams, we want to let it getting cut in half 1, 2, 3 times. All right, because the amount of time for each of those to occur is this, and if you allow that to happen 3 times in a row, this is the total amount of time that would have passed in that amount. All right, so we just keep cutting that in half. That's going to be 72. All right, taking 72, dividing that in half, that's going to be 36. 36 divided by 2 is going to be 18. All right, and that's going to be grams. So we can do the math here and figure out that that would be a total of 4 half-lives. So this problem actually asks you to do things a little bit differently. It tells you how much you have in the end, which is 12.5 grams. All right, and then it asks you to work backwards to figure out how much would you have had in the beginning. Well, if that's after 4 half-lives, then 1 half-life previous to that, we would have double that amount, which would be 25. Another half-life would be 50. Another half-life would be 100. And then another half-life before that would be 200. All right, so if half-life is the amount of time that it takes something to get cut in half, then if you go back in time by a half-life, you would have twice as much. All right, so again, that's a total of 1, 2, 3, 4 total half-lives. So the amount that you would have at the beginning of that would be 200 grams. All right, and if you wanted to check your work, just ask yourself how much would be left from a 200-gram sample if you allowed 4 half-lives to pass, and you would see that the answer would be 12.5. All right, so hopefully you can solve those types of half-life problems. That's it for this video.